So in the representative elements lab, we saw several elements react with water and hydrochloric acid. Some of those include sodium, aluminum, and potassium. Now we saw generally that the sodium was quite reactive and the aluminum was not as reactive. Part of the reason why includes core charge and shielding. Now, if we look at sodium and aluminum, sodium has a core charge, I'm going to write it above the atom, of +1. Aluminum has a core charge of +3. Sodium has 11 electrons, 10 of them are inner electrons, in energy levels 1 and 2. So we have only one valence electron. So protons minus inner electrons, core charge of +1. For the aluminum, we have 13 electrons, 10 of them are inner, 3 of them are valence electrons. So 13 minus 10, core charge of +3. Now the shielding for sodium and aluminum is the same. We have two levels of shielding, two inner energy levels of electrons, which make the shielding for this atom, n equals 1 and n equals 2. So the distance from the nucleus to the valence electrons is about the same for sodium and aluminum, but aluminum has a higher core charge. So in terms of reactivity, because it has a lower core charge, sodium tends to give up its electrons a lot more easily, where it's one valence electron. Aluminum tends to hold on to its valence electrons more strongly because of its higher core charge. So this is a way that we explain the higher reactivity of sodium and the lower reactivity of aluminum, the fact that aluminum has a higher core charge than sodium, and sodium really wants to give up this one valence electron. It does that very readily. Now if we look below here at potassium, I'll let you think about how potassium reacted and why, but consider potassium has the same core charge as sodium, +1, but it has 3 levels of shielding, not just 2. In this atom, n equals 1, n equals 2, and n equals 3, those are all shielding layers. So that creates more distance between the nucleus and this one valence electron. So potassium gives up its one electron even more readily than sodium does. Core charge and shielding, they do have an effect on the reactivity trend.